Okay, my name is Jos. He's Nico, but probably most people already know that. We're going to give an update of what we've been doing on LionWeb over the last year. First, a very small recap of what we presented last year. Basically, we have a mission, always nice to have a mission, and we want to create an ecosystem of modeling tools that can interoperate with each other. It's like Marcel said, there are so many wonderful tools out there. It would be great if they can all talk to each other and you can just pick the tool you want. So I'm looking forward to the type checking tool I saw yesterday to use that in a LionWeb context, for example. And we think that as you can see in this room, we are relatively small communities, so we should build upon each other instead of building all kind of separate things. So it will help adopting because there are more possibilities, less vendor lock-in, mix and match all the kind of components and just use the boring components from others so you can focus on the really interesting new components that you want to build. We have a reference architecture in mind. It's not prescribed, but it's nice to see it because that's the way we think. We assume that there is some kind of model server in the middle and there are models in there. And that could either be models which we call original, which people edit, etc. But they could also be derived models. So, for example, a type model is typically a derived model usually. You don't do that yourself. And then we have clients, like editors, who interact with the repository. And they can be visual, projectional, textual, graphical, whatever you like. And we assume that there are also automated clients, which we call processors, which just look at the model and then, for example, calculate the types or do validations, and they could be incremental or not. And typical processors also importers and exporters or generators to connect to the rest of the world. And the parts you saw changing from black to orange, that's where the focus of LionWeb is. It's not on the clients or the model server itself, on the tools, it's on how they connect with each other. So it's the protocols, how do they talk to each other, and it's the contents of the protocols. And all the green check marks are the things that we have finished. So we have a bulk protocol now. Delta protocol is a protocol where you can send changes around instead of a complete set of nodes. We're working on it, that's why it's not completely green yet. And you see the derived, which is dotted, that's really under discussion. That's quite a complex thing to do. Reference, you can see our talk last year, and then we have a complete demo of how we connect a bunch of tools. We don't do a demo today. And we have on the web a lot of working documents, a roadmap, what are we planning to do in the next period, reference architecture, use cases, everything is there. Usage. This was part I was doing with you.
You continue, I don't remember.
Okay. Like here, we give presentations and talks at different kind of conferences and meetups just to spread the word, to explain to people what LionWeb is, and hopefully get people to actually slowly introduce them inside their tools. We have actually real-world projects using LionWeb, and that's a success in itself, we think. Trumpf is a German customer. Maybe you can explain what Trumpf is doing. Can you get it?
Yes. Yeah. Microphone gymnastics. Yeah, Trumpf, they build lasers, like really the light that cuts stuff. And they had the problem, they have different applications where people can look at the stuff that the lasers does, and from the user perspective, they all look the same. Internally, this was, I always forget the law that your software follows the organizational structure. And this was a very much an example. Different departments designed this different software, so technically they had nothing to do with each other. And that is not useful for customers, right? Because for them it looks all the same. And we now help to rebuild this, and the base technology to exchange the contents is LionWeb. The other example we saw yesterday, Strumenta Inside Studio, a great demo of Federico yesterday evening. There we also saw that this scales quite well. And then there is another one where Jos knows more about.
Yeah, that's a Triradial. That's a US-based company, and they build software to support people defining clinical trials for new medicine. And there's a whole schedule and protocol and things you should do at certain times, etc., that should be repeated. And they're building a front-based WebDSL for that, and they use lionweb for the storage of their models, which also makes it easily accessible for generators that can hook on, that then generate stuff that goes into the pipeline of the company using it. And it was a front-based WebDSL. Actually, they have a complete application, and one of the windows is actually a front web editor, because there's also stuff in applications which is not model-driven, like nobody knows in this room. But and the idea is, and that's not finished yet, is to have a runtime system which takes the model and understands what needs to be done at what time, so people actually running the trials know what to do and can't deviate from that. We have a number of companies or tools that are expressed interest in integrating JetRange Web MPS. They're planning to use lionweb. Pedro Langdev is planning to use it next year, I think, hopefully. Wimbus Modeling Group, Declare is interested. Meinte here. Technical unit that does spoofx. We talked with them once. Have you?
Oh yeah, they're still interested.
They're still interested.
And as always, and as with everyone, they lack time and funding to properly execute on it, because they're well, yeah, it's an academic thing, so they produce papers and not software. But they're interested.
Okay. Everybody's interested. Time is for everybody a problem, even for the people in the lionweb team. That's sometimes a problem. There's a blog from Typefox about Langdev, about how they see and envision to connect with lionweb. And Typefox type here, as you said yesterday, somewhere there might be time to do that. Yeah. I'm looking forward to that. Well, this whole session is about lionweb. Oh, actually, no. This whole session is about things related to lionweb. Its tools and things doing using lionweb. Spec work.
Yes, I would continue.
Yeah.
Yeah, so as we say, the main thing we do is protocols. So the core is actually specifications. And we established a way how we can work. There are some, as you might imagine, some documents of our specifications, which you can find here at the linked here. They're all public. And the idea we have is that the specs are really like as concise as they can be, but we want to capture a little bit like architecture decision records in this idea. You want to capture the alternatives and the thought process and the rationale, and we put them in GitHub issues. So on this repository, we have like more than 250 issues. Half of them are closed, and I guess of the open ones, a quarter of them is almost closed. And in these ones, we try to do the discussion. So like list the pros and cons of different options and the rationale why we chose for one, and the specs then refer to the issues. So if you really want to know, you can read up on the details. And to actually keep ourselves going, we meet weekly. Now for more than 2 years. This turned out way better than we expected ourselves. Still people showing up pretty much every Friday. And there, we discuss the specs, and we kind of adopt this idea from IEEE, right? Rough consensus in running code. We want to write specs, but we also want to make sure they actually work. So we actually implement quite a bit of things, which you will see in a minute. And yeah, for this stuff we keep some logs. And yeah, then we have a lot of implementations, most by the LionWeb team, but they guided by these real projects we've seen. For example, the C# implementation was created in the project of Trumpf. Yeah. So what we currently have, the spec of last year is released. Thankfully, we hoped to have the one for this year ready. As you can see, not really yet there, but we already know what will be in the bulk protocol is done. We essentially implemented structured value type, yeah, as you see here, and spent quite some time writing test suits, so to see that all the weird cases that you can specify write in the protocol and that might or might not be supported. And then for what we're currently doing, Delta protocol. So we have to all the major issues we've seen or we can foresee, we discussed. So we want to now start implementing it and then probably figure out that we got it all wrong. I think we have a pretty good common understanding what we consider to be correct in a language and a model and a protocol, but we should actually write it down so other people can reproduce that. And for derived models, we actually started this discussion before we started the Delta protocol, but it turned out that was the wrong order. So at some point we said, no, we're in a very deep hole here, so let's pause this, continue work on Delta, and then come back to derived models. So, and then some example, which Jos will continue.
Okay. The bulk protocol is a protocol to send large chunks of models back and forth to a server. And it's basically a complete model in LionWeb consists of partitions, like a root node with a bunch beneath it. And we have simple create, read, and delete partition commands. We have a retrieve command, which says, okay, give me a subtree of this node with a certain depth. Could be infinite if you want everything, or could just be very limited. We have a store command, which is more complex, and it just says, okay, I'll have a subtree here, and make sure the repository reflects this tree. But the repository doesn't just bluntly store this tree, it makes sure that the contents of the repository remains a tree. And it makes, for example, sure each node has exactly one parent. And it makes sure that the node IDs are unique. So if you send a new node with an ID that's already used, you get an answer that's wrong. I'll explain on the next sheet what this actually means. And we have a ID commands where you can get a collection of IDs that you can use offline to create new nodes, because you want to make sure they're unique and only the server knows which nodes are in use currently. So how does this store thing work? Say I have a repository with a tree and I send a store subtree request where I have a node C with some children. And as a result, I have a repository after, which looks very different from the one before as you look. And I want to point out two things there. One is, in the request, node B is a child of node C. And in the repository, it was a child of node A. So even though I don't change node A in my request, the repository knows, oh, if it's now a child of node C, it can't be a child of node A anymore. So it removes it as a child from node A as a consequence of that. And another interesting one is, I send node C with all its children, which are in the request are B and F. Which means that the node G, which used to be a child of C before, is clearly not a child anymore in my request. So node G is removed as a child. And since it's in the same request not attached somewhere else to another node as child, it implicitly is deleted. So there is logic which we defined to make sure that the server always, after each request, makes sure that the tree is correct. Usable code. We have lots of usable code. I was actually, when we prepared this presentation, I was surprised at how much we actually have. Well, we have an implementation of a lionweb-repository that implements the bulk API, and it does guarantee that the result after each request is always a proper tree. The server and also the specs say it's language agnostic. So you can say, as long as you have a proper tree, it's okay. The server does not need to check whether the structure is correct, conforming a certain language definition. Of course, you can optionally add that, but that's not something that we require. Because in general, we would like tools to be able to work without knowing the language. That makes things much more flexible. Supports multiple repositories. The repository also has the option to have history or not history, so you can walk back in time. And you saw yesterday in Federico's presentation that he's storing quite a lot of nodes, like millions, in a repository, and he has developed some additional optimized methods for uploading huge models. They're not part of the bulk API, but they are part of the implementation to make it usable for his use case. Implementation is PostgreSQL as a backend. The server itself is written in TypeScript, and it reuses a lot of the lionweb TypeScript implementation, which we see later, to do all kinds of things like diffing and merging, etc. There is a TypeScript repository client to make using it easy. We don't do things like authentication, because it has nothing to do with our mission. You're supposed to do that the way your company or your institution wants to do that. So we say nothing about it. It's a Docker image that we distribute, or you can use the source code. Well, another project is we've created a front web editor for the M3 of lionweb. So it's an editor where you can create lionweb languages or edit lionweb languages. And it loads stored to the lionweb JSON format, either on file or in the repository, just like you want. So it's easier to see and change those meta models. And now it's to you.
Yeah, thanks. Yeah, okay. Now we see quite a few of libraries, and you see there is a lot of stuff here. I will not go through all the details. I will highlight a few things. So, of course, for all our libraries, we need to serialize and deserialize our actual format. And then we provide an API to work with these nodes. And here, does this? Yes, it has a pointer. You see, for example, here we say we have lenient nodes, which is a term I invented. It means these kind of nodes accept wrong things that are wrong according to the meta model, which is very interesting for migration use cases. And then, for example, if you compare it with Java, there we say you have proxy nodes, which is something else, right? And this is actually not a bug. We consider this a feature because the Java library was developed by Federico for his use case, where he parses a lot of stuff. It's very important to represent dangling references because you have them a lot. For the C# library, which we developed in the Trump context, you want to migrate languages, right? And there might be, you might get an older version of a instance file which somehow does not adhere to the newest version of the language, but you still want to process it. And that's why you have the lenient nodes, because then you can still load it. You don't need to fiddle around with it on a very low level. You can essentially work with it like with regular nodes and can cure the problem or migrate it to the newer version, and then and this still on a nice API level. We have also in C# we have a generator built in Roslyn to generate C# representations of our classifiers. Works quite well. we have the usual utilities. Yeah, we have them in most languages. You want to navigate through your tree, like descendants, parents, targets. In most of the tools, we also have tools like clone this subtree or compare this subtree to the other one. You want to write tests, and you need a comparer. And especially for C#, we have pretty extensive test coverage because you can find very weird cases how you can try to break the node structure, like tree structure, and I'm relatively confident you will not manage with these ones. Java, yeah, we have the dynamic things. This is the binary wire format. That's what Jos also mentioned, implemented by Federico, because yeah, if you send several gigabytes of nodes, it actually, even with compression, makes a difference whether you send them as compressed JSON or as protobuf. Actually, not so much what's on the wire, but the parsing and serializing. So this makes it a lot better. And here also, notably, we have image exports for EMF. Kotlin it reuses the Java stuff, so that's why not so much of this listed is here, but you have the nice APIs of Kotlin and also the client that Federico uses to talk to the repository. TypeScript, yeah, I will not go through the stuff. That's the same as in all the other ones. Again, we have lots of the tools. We have a differ, we have a validator. There are some more interesting tools, for example, to check that the models are actually correct to several ideas of correctness. That's what you still need to write down. Or you can generate diagrams. Or you can also measure, right? It's interesting to say, yeah, you actually have this concept in your language, but in all the instances you gave me, it never appears. So do you really want this? We have an MPS plugin, so we can image export stuff from MPS. For M1, it works pretty good. For M2, exporting, so going from MPS to lionweb also works. Importing works in principle. It's only MPS reacts very aggressively if you try to create languages it doesn't know about. You really need to fight there. That's why I put it on the experimental part. Also, some of the things that MPS knows about, like virtual package and things, yeah, we don't have this in lionweb, but we have annotations where you can stuff everything in that doesn't fit anywhere else. So we have an automatic translation to store this. And implementation of earlier versions of the bulk protocol. I didn't get around to update it to the current one. There's a ModelX plugin that's not complete for references. It supports only single-valued references. lionweb supports multi-valued references. And this actually does not only work for modelware, it also works for grammarware. So there is a plugin for Rascal. And I will actually not tell anything about it, because if you stay seated for half an hour or so, you will hear all about it. Yes, and I just saw the 1 minute sign, so we're through. And so here you see the core team. Pretty distributed, different companies, different kind of, okay, lots of consultants, but this was actually one of the reasons why Trumpf chose this, because they're very much the opposite of vendor lock-in, right? It's lots of people, they can get consultants of lots of different companies. They have a relatively high chance that this does not die if anybody has an issue. And yeah, we're very happy to work with all of you. We work on Slack, and that's also what this QR code brings you to. And this, you might have seen the presentation is full of links, so it will be available, of course, then you can follow all of them. Thank you.
So, time for questions. Is there anybody with a question? No? Just so crystal clear?
Why the trees as a basic data structure? Why not graphs? What is the reason to choose that?
It's both a tree and a graph. It's a tree if you talk about composition or containment. But of course, there are references which go all over the place. So from that perspective, it's actually a graph. So depends how you view it.
There is the one important difference. We do allow dead references. So you can have a reference which doesn't point anywhere. You cannot have a dead containment. So from a structural point of view, we need to guarantee the containment. We are okay with broken references. So that's why this makes a fundamental difference.
So there are two kinds of references, containment and non-containment.
Yes, exactly.
But once to containment, we don't call them references.
Yeah.
Just to make a distinction.
And also, yeah, the whole idea of this, yeah, we didn't have it in this slide deck, right? Federico said this very nicely. We try to be boring. We don't try to invent anything innovative here. This is, the meta model looks like any other meta model you've seen. It's the same as EMF and as MPS, as all the others. And also this idea with references and containments is the same as in EMF and the same as in MPS and the same as in, yeah, okay, I don't know the grammar good enough. I will not say anything about it, but it should pretty much work as you expected. So.
Oh, yes, I want to ask about how are you governing the Lion Web? The governing procedure about how you organize to deal with this.
Yeah, organization. So we try not to, mainly. No, seriously, so far we try to keep it as little as possible and get things done. We are aware that, yeah, at some point we probably need to formalize this a bit. The first thing where we thought about is just who owns the domain. I think at the moment, technically, it's Federico. And at the moment, we trust him enough that he will not do very nefarious things with it. But I guess when this gets to some point, we will need to probably join one of the usual suspects to just get under their umbrella. That's my opinion. We haven't discussed this, but.
No, we postpone the discussion on that as much as we can.
As commented before, we wanted as Metadep just to join and to offer, for example, the kind of thing we have been working on, like, for example, in the collaborative space. But last year we make an approach to join the group, but all say yes, but maybe the request was lost in time, so maybe this time.
You want to join Langdev?
Yeah, we will definitely want to join as a core member and to be part of that weekly meetings and contribute openly.
Okay, yeah, okay, then we very much need to discuss this.
We don't have a procedure for that, so.
I was asking.
But we'll talk about it, yes.
Actually, my colleague missed his duty because we are a space conference, so we know everybody needs towels and space. So that's good. Okay.
Okay.
Well, let's thank Jos and Nico then. Okay. And